Hey, Gall.
Hello, Laura.
How's the weather where you are?
Not too bad. Unseasonably cold, but that's usually a good thing. How about yours?
It's pretty warm out here, but I'm in the Bay Area, California. I'm enjoying the Hawaii weather, at least for now, before it
Very
just
good.
burns up. I heard you might be running out of gas where you are. Is that true?
No, why would you say that? Something on
I
the
heard,
news you saw?
yeah, something on the news that there's a long
Hmm,
line pumping, waiting for gas. I just hope
weird.
you're not one of them.
Nope, nope. I'm good myself. But yeah, there's definitely some interesting social dynamics based on ransomware these days.
I'm sure we're going to talk a little bit
Maybe we
about
can
cyber.
about that.
Yeah, well, we're going to talk a little bit more about cybersecurity along the way. Let's get started with our meetup.
All
Everyone,
right.
welcome to the Future of Data Meetup. My name is Laura Chu. I'm a Senior Product Marketing Manager for the Data in Motion product team here at Cloudera. So, a little fun fact about me. I am pretty much a California girl. I grew up in San Francisco. I'm a big 49ers fan and a Warriors fan. Yay, they're winning. But I also spent a good chunk of my career on streaming technology, and trying to get our customers to adopt, streaming technology for real-time insight, real-time analytics. So for today's topic, we're going to talk about solving the first mile of the data pipeline, and that's going to help you accelerate your analytics. Something that we don't talk enough about, and we're going to spend more time diving on it in this meetup. So if you are visiting us, whether you're on LinkedIn, Twitter, or YouTube, thank you for joining us this afternoon or evening, wherever you are. We will be monitoring questions, so do go on your chat, ask questions as we go through the presentation. I'll do my best and collect them and make sure I'm able to answer them for you. The next thing is we're going to have a raffle. So everyone that participates in this meetup and also the chat will be drawing into a raffle. There will be a total of two winners, first prize and second prize. You can see that on the screen. So a random drawing will be held at the end of the presentation, and you must be present in order to win. So next, we're going to introduce our presenter. This is Gall Spencer.
Hello,
Uh,
everybody.
Hi, Gall. You're an amazing architect that I knew. You and I haven't directly worked together, but we have customers that we work with that have
Yes.
done amazing thing around data pipeline. So I would love you to introduce yourself, talk about your past experience, and one fun fact about you that we all need to learn. Take it.
Sure. All
Go
right.
ahead.
So I've been doing security for about 20 years now. Before that, I was in the physical security space and got into information security because I realized that it was possible for some people to read my 15-minute line-by-line itineraries that I was responsible for protecting people and places. So I thought that was unacceptable and got drawn into cybersecurity and information security. Computer security was called back then, and then went full-time. Most of my career has been consulting to CISOs, but in the last 7 years or so, from 2014, I've been doing virtual CISO work and working for very large firms, depending on the particular engagement. The virtual CISO stuff, I've done work with small tech startups and NGOs, all the way to over $1 billion revenue per year firms, and did a lot of work with .edu, nonprofits, NGOs, VC funded startups, up to and including the Mega Global Corp, and a couple of environments where I helped with standardizing stuff is the energy sector with the privacy framework for smart grid that came out as a global standard in 2009. And then with the ESC2M2, that was the self-assessment for the electric sector, and that kind of grew into what we now know as NIST CSF. Never had a 9-to-5 job. I'm a consultant, and I like to work with people in short and long-term engagements. And I can be found on LinkedIn or just Twitter at Sponsor. And I'm not here to sell you anything in particular or even generally. Just want to help you understand what's available out there in the open source community. And obviously, Cloudera supports the open source community and clients that use it. So
That's great. Well, you missed one thing. What's one fun fact that you want us to learn about you?
Well, I thought I threw it in there that I used to do physical security work beforehand, but maybe that's not as fun as I thought it was.
No?
I guess I stalk birds in my free time and get bit by ticks and red mites and mosquitoes while I'm doing that. Maybe that's fun for some people.
Okay, well that sounds fun.
There you go. Photography.
Yeah. Well, let's take it away. Let's go ahead and start with the presentation. So we've got an agenda here. One of the things we want to talk about with Gal is about the log data pipeline challenges that we're seeing and experiencing with customers, and how Cloudera data flow can really help with those challenges. We're going to cover some of those use cases where modernizing your first mile of the data pipeline will really help benefit the customer. And then the most exciting thing is Gal is going to talk about his best practice, and he has a good list of it. And some of them are really interesting. And so you guys should really stick around and hear that in detail. And we'll definitely end it off with a Q&A and, of course, the raffle I talked about earlier. Next slide. Mm-hmm. So you can see here that every time you and I are logging into a desktop, it's being recorded, whether you're logging in, saving a file, going to an app. But oftentimes, if you're either a log analyst or a cybersecurity analyst, all you care about the important events. And some of those important events is someone that's logging into your laptop that's not you, decide to disable the firewall and start doing something. And that's an alert. And we would love to detect this easily, right? But the reality, if you go to the next slide, if you're in a Fortune 500 company and you have over 100,000 desktops used around the world, it's really hard to detect those events. So what do? You turn into a log analytic solution. Next slide. And the log analytic solution, you typically use a SIEM application like a Splunk, and you collect log data from your desktop, but you also collect data from other sources like applications, your data center server and storage. And you now start using Kubernetes. So you want to collect logs from those Kubernetes. And you realize you're putting all your data into one application to do your log analytics. And afterwards, you realize you built this giant data lake just for one app. Does that make sense that you're using one application for one type of analytics just for this one data lake? It also doesn't make sense. If you go to the next slide, I think what all enterprises want to do is to build a modern log data pipeline that can send the information to different analytics apps. So for a data warehouse, you want to use log data to run reports, look at historical events that happen. Or if you want something smarter, you want to use your machine learning capability to detect anomalies. If you want something really fast in milliseconds and you want those alerts immediately, then you want to start using streaming analytics. And then if you want to do forensic analytics and figure out why those events are happening, you use search analytics like a Splunk or Solar Lucene to do that. So you can see you need different analytics apps to do the various type of use cases. And the only way to get these or enable these analytics application is having a proper data pipeline to send the information to those apps. Next slide, please. So I have a poll here. I'm looking forward to all of you giving me a thumbs up or down. And the question is, are you building and maintaining the data pipeline for the user's needs? I'm really curious to see how people are responding. I've got someone who's collecting the information for me. I'm going to wait maybe 5 more seconds. And if Bill can give me an answer, that will be great. So I think the majority of the answer is thumbs up. So we're seeing that a lot of people are already knowing they're building and maintaining a data pipeline for the user's needs. So that's interesting. Let's go to the next slide. So really, the way to optimize your data pipeline is to modernize it. And what do we mean by that? By using Cloudera Data Flow, you have the ability to distribute and data collect and process all that data and able to all your various applications. And your goal is not just doing that. You want to have the ability to look at all the historical view and current view and able to enforce governance, which I can explain a little bit more what I mean by governance. And at the end, you want to optimize your data pipeline for higher productivity of your data analysts and also maximize your data lake efficiency. So you're not building a data lake for just one use case. You're building a data lake for many different use cases. Next slide. A great example of what we mean by distributing data collection and processing. So in this use case, we have a customer that wants to collect log data from multiple environments. They want to collect logs in the server within the public cloud environment. They also want to collect logs from the desktops around the world. And they want to collect them and able to process data and break it out and send some information to their SIEM application and some to the cloud for analytics. And you can see that this is actually pretty complicated because you've got on-premises, you've got the cloud, you've got data sitting all over the places. So you need something like a Swiss Army knife to have the agility and flexibility to able to collect data from different operating systems, having the edge agent to collect and process the data at the edge and stream that data down to a NiFi and able to distribute that data to the way you want it for analytics and speed, right? This is where it's really unique by leveraging Cloudera data flow with edge management and flow management. Next slide. So here is an example what we do in that data flow. We collect that data from the devices or desktop. We transform that data. Some of them we're going to transform it to JSON, and some of that data we're transforming it to CSV. Why? Because in certain situation, we just care about a certain amount of data that goes to a SIEM that requires that particular format. And then for the rest of the data, we want to store it for historical reasons or data warehouse reporting. We send it to maybe a cloud environment to do more historical reporting, but that requires CSV file. And all of this, it can easily be done through our NiFi capability. But why is this important for governance? As if you're in a IT team or a cybersecurity team, if you discover data and you're trying to figure out where it came from, we have a data lineage system that helps you identify where the data ended, how it was processed, where it originally came from. This is the data lineage that's going to help customer who has GDPR or regulatory rules, they're able to identify how that data came about. So it's easier to detect. And this is something that's unique because not all data have data lineage, and we provide a capability with our shared data experience. Next slide, please. One more.
Here we go.
And then we optimize the data pipeline. Remember I talked about earlier on the left, you're building one app for one giant data lake. And really at the end of the day is you want to better optimize your data lake by having it able to do multiple analytics. So having the able to ingest those data and collect some of them for your cybersecurity related, and you can have some of them for your streaming analytics, as well as some of them for your machine learning or data warehouse. You can do all of that with our Cloudera data flow and with Cloudera data platform. Next slide over. So I have another question for you. Are you sending all your logs to a cybersecurity application or a SIEM? I'd love to see who are the majority. Are you thumbs up? Or are you thumbs down? So let's give 10 to 15 seconds. And let's see what are the majority of your response. A couple more seconds. And we're seeing that not everyone is sending their data to the SIEM. Okay, that's good information. Let's scroll to the next slide. So here's a customer use case where they were able to reduce their data going into Splunk. So you can see that before they didn't have NiFi, they were ingesting 800 and I'm trying to see this, 850, it's a little blurry on me, 860 gigabytes of log data going into Splunk. And then once we were using NiFi to able to process that data using Minify the edge and distribute it by NiFi, we were able to reduce that log data by 60%. And because of that, we're helping our customer to reduce their Splunk costs by $2 million over the 5 years of the license costs. The other thing that we didn't spell out here is we probably help our customer reduce their infrastructure costs, which is the compute that's necessary to process all this data, as well as storage. The other thing we help significantly through the data pipeline is accelerating Splunk search. In the past, without NiFi, it used to take 22 minutes to do a complete search, whereas with NiFi, by transforming the XML data to JSON, we were able to accelerate that search by 55%. Instead of 22 minutes, it's now 10 minutes. Next slide. And same thing here. This is more of a cybersecurity use case where they're using a scoring system to determine how to detect an event faster. And without NiFi, it used to take 70 minutes to detect an event. But then once they add NiFi plus a stream processing engine, they were able to accelerate this mean time detect by 90%. So from 70 minutes to 7 minutes. This is what we mean by if you modernize your data pipeline, whether it's a first mile or half a mile and so forth, it really accelerates your analytics needs from slow to super fast. Next slide. So Cloudera Data Platform enables it all. What it does is it provides our customer the ability to access the different types of streaming capability, analytics capability, whether it's a data warehouse, data engineering, operational database, as well as our data flow capability and streaming capability. All of this is able to run our Cloudera Data Platform. And what's great about our Cloudera Data Platform, it's designed for multiple environments, whether it is on-premises, private cloud, hybrid cloud, or multi-cloud, whether you're on AWS, Azure, or GCP. And I think that's the transformation is with our customers, they're able to leverage any one of this environment, whether it's a public cloud or a hybrid cloud or a private cloud, and able to still manage their data pipeline in a very efficient way and able to leverage NiFi and Minify to do the 1 mile data pipeline or modernizing of the data pipeline as they need it. So right now, next, I'm going to let Gal talk about some of the principles that he has in enabling that 1 mile data pipeline and modernize and make it successful. Gal, go ahead.
Thanks, Lauren. Thanks a lot.
Yep.
So a little bit about myself, just some specifics about why I'm working with the Cloudera team on popularizing or explaining this idea. I work with a very large company to work and select actually Cloudera as the main vendor to implement a larger vision of re-enabling very fast analytics with a forward compatible pipeline. And Cloudera came in and implemented the vision and created the effects that we wanted, which was to reduce the mean time to detect by a significant amount. We had a very complicated hybrid multi-cloud situation where we had a very large on-prem global network. In addition to all the major public clouds, we had things generating telemetry in Azure and AWS. We had analytics in all 3 major clouds as well in terms of SaaS vendors. In addition to the IaaS and PaaS stuff, tens of terabytes a day of net new inbound logs and growing. And the big thing was the diversity of the sources, of dozens of sources already, and many planned to be onboarded. We then built the petabyte data lake in Amazon, and that resulted, when we're speaking about specifics of the first mile, they ended up deploying the largest supported Minify deployment in the world to all their servers and desktops, which added more telemetry and more ability to ingest the right kind of logs and act on them very quickly. And in addition to the Minify piece, obviously the main resources that we were using and scaled up in the pipeline itself were NiFi, Kafka, and Spark, and then later added things like Flink and hopefully other things like Druid. There'll be some Top Gun lyric and visual references here. Don't sweat it if you don't like that movie. Just a little throwback to the 80s. So really the focus today is the first mile, but also the last mile. So first and last mile is a kind of a telecom term or a physical pipeline term where you have to distribute, you have to gain all the data from the sources and you have to redistribute the data to the people who need it, whether it's television viewers with high-speed bandwidth like fiber or cable, or in this case, it's consumers of data that need to store and analyze the stuff. So what is an example of a first mile solution that we used with, for example, NiFi? We had Kafka in the vision, but we also, when we added 100-something thousand MiniFi agents, there was an issue with actually scaling the concurrency, which is a simultaneous write into Kafka, direct write into Kafka, and it's not really designed to do that. So we ended up using NiFi as a middle tier first mile. So all the agents wrote to NiFi and then NiFi wrote to Kafka. Now there's a sheer diversity of producers or sources and also a sheer diversity of consumers or sinks in the kind of data engineering terminology where they're physically in different locations, on-prem, and there are various clouds, even between clouds and inside of a given cloud, you have to move data around in some cases where they're not fully wired in with native services. And then the same consumers and producers started growing in different locations. So the same type of consumer, a Windows server on-prem, but also in Azure, the same type of consumer of producer, a OpenShift container on-prem, but also in Azure. So we need to be able to move data with repeatable patterns. And like Laura said, the Swiss Army knife, that first mile was really where NiFi came in and just cleaned up all the things. So one example, again, containers and on-prem versus cloud, but also syslog in the LAN versus we actually log from on-prem over the WAN, the public internet, to a waiting consumer on the public cloud. And so you don't just do syslog for that. That's not really what it's for. So you have to get data from all these producers, wherever they are physically and whatever type they are, whether it's a virtualization all the way to the application layer with database and OS in between. You have to get the data to the consumers, and that's that last mile. And then you have also the intra and intercloud data movement, which is not easy. Like Amazon and Amazon and Azure don't make it easy for you to move data between them. You kind of have to be able to hack that. And we found NiFi to be quite a good thing to put in Amazon and Azure to be able to move stuff between them. And examples of what's called processors, or these little add-ons into NiFi. Many of them are built in. Some of them you can just add later. Things, for example, Ingress First Mile, a listen syslog. Obviously, it is what it sounds like. NiFi can actually impersonate a syslog server, so you can get rid of your syslog servers when you bring in NiFi. You just turn on the listen syslog processor and send it to NiFi. It does listen HTTP, get SFTP, and many other dozens of others. Ingress kind of give me the data so I can aggregate it and move it downstream to things like Kafka and Flink and so on. Egress is the last mile, and in some cases you want to put an alert into an email system or into an SFTP. Certainly you can do post HTTP, and then even things like put Kinesis, a more modern kind of cloud native Amazon Kafka-like streaming ingest services. And there's things like route on attribute where you actually have policy-based routing based on various types of triggers. So it's a very flexible tool that I found is not just very scalable up, but very scalable down if you're doing it correctly with the right physical implementation. And then you're looking at the ability to just ingest and redistribute almost anything as that first and last mile, in addition to the policy-based routing and all the tagging and enrichment and governance that Laura talked about. So I found that even in some cloud-native environments, like for example, we had containers in OpenShift on-prem. Those were, built in with some of the cloud-native modern processing, and it was supposed to go from FluentD built into the OpenShift container or the EFK logging stack. It was supposed to go directly to Kafka, but we actually found that trying to connect the FluentD from the container platform into Kafka was harder than connecting it to NiFi and then into Kafka. So I found an amazing versatility and durability for NiFi as that first and last mile. And they're constantly creating new processors. So a little bit of Top Gun reference, you've lost that logging feeling. And if you have, here's an example of how you've lost that logging feeling. So this is really about security from my point of view, but at the end of the day, data doesn't care if it's going to a CISO or a CIO or CTO type of analytics or storage platform. The data is the data. And I like DNS, for example, and we have proxies and EDR, which is a little bit of forensic flight recorder for what's going on the endpoints, Windows Server and desktop logs. Let's say we think we may have been compromised, or we're proactively looking at if we were compromised, and we need the last 90 days of logs. And so they come to you and say, hey, we need these logs. They give you the list and the timeline. So in the reality of the messy kind of default world of logging pipelines, which people just accumulate over time instead of engineer this way, who would you ask to do that? So you typically would ask the owners in IT of DNS and maybe the people who operate the proxy and EDR. So each of those teams would have kind of ownership of where the logs go. And maybe you have some sort of storage area where all of those are there, but in some cases, the SIEM group is the only people who have the logs, but then it's been kind of proprietary formats now and stored in a post-index environment where they're not in the raw native format whence they came. And so it becomes a bit of an exercise in data engineering of getting those logs. And the question is, who would you ask? How many people would you need? How fast could you get this done? A pretty simple request, 5 or 6 sources for the last 90 days. And then how often could you do this? Because this is happening more and more often because more and more people need to answer questions to protect the business or to make the business more profitable, more efficient. So do you have a repeatable and a scalable approach to doing this kind of thing? Is the data that you're going to be giving to the threat hunters or whatever group is requesting it for whatever reason, is it real time or is it more historical? How stale is it? And how do you get to work for timely updates if they need them? So the next day, the next week, or the next hour, or even several minutes that give me the latest arriving data. The reality is that most enterprises struggle with this. And that's the issue that we're looking for. So one of the things we can talk about here is, again, this idea that all of the people who are dealing with technology, whether they're using security tools to protect the company or they're implementing IT and cool stuff for applications for consumers to use, or the people are selling a platform that's typically in the CIO and CTO group, and the CISO helps protect that value. So in DNS, for example, one of my favorite logging sources for both IT and security, these groups look at the same data slightly differently. So security needs all the needles and all the straws in the haystack, and we don't know what the needle is. It's just a straw until we know, oh, that looks like a needle. Actually, it's something dangerous. Because at some point, maybe 3, 6, 9 months later, after the initial hack, we get notified by someone. Brian Krebs calls us, or someone says, hey, we found your stuff on the dark web, or the FBI calls you, or you actually figure it out yourself, or you get some threat intelligence that says, look for this particular hash of a binary or this particular URL where the DNS came out to a command and control channel, for example. So we just have to deal with the fact that we can't do sampling and a lot of aggressive data engineering techniques because we need the entire haystack, including every component of that haystack, because we don't know what's malicious yet in real time. In many cases, we just have to store it for almost forever, 6, 9, 12, sometimes 18 months or more, because we want to be able to retroactively say, aha, now that we know it looks bad, we go back and search for it. Do we have this? Were we affected? And if so, how? And that because security focuses on malice. Whereas CIO and CTOs, they generally need to know the haystack's kind of shape and color and size and the changes in those types of attributes as an abstraction, because they don't need literally every log from every application piece of network and endpoint to understand what's going on in their network. They want to look at uptime and performance and efficiency and things like that, and do troubleshooting, but they don't literally need every straw in the haystack. So the reality is, while I'm a security person, I've also worked with CIO and CTO folks, because they can even more aggressively use these data engineering techniques that we'll talk about, more so than the CISO, because of this fundamental difference. They can do aggressive sampling and other destructive techniques, whereas that doesn't really preserve all the data in every log like the CISO groups need. So I hope you're not turned off by the security focus of this idea. Of the project that I came from was sponsored by the CISO, but the CIO and CTO folks very quickly understood that their troubleshooting applications and their applications that were helping the developers get better at doing IT and doing development were in fact positively impacted by this idea, because we had this reusable pattern to get all the data they needed to somewhere they needed it to be in, whether storage or analytical tools outside of the main SIEM that security and IT used. So reality again, this is what most people's pipeline looks like by default. It's a bunch of cruft, aggregated and disorganized over many years, in some cases decades. It's usually a bunch of scripts that are not centrally managed, and they're not certainly centrally secured. And there's a lot of change management issues there and a lot of potential for failure and heartache because no one really owns all of these things. Typically the log source owner puts a script together and says, here's some of the data that needs to go from, let's say, Apache HTTP server on the top left to Elasticsearch in the middle right. And that's the example of producers on the left and consumers on the right. So we want to be able to say, you know what, we're going to untangle this. I call this the spaghetti ball of pain. And we want to untangle the spaghetti ball of pain and make it a little more efficient, more modernized. So in my journey as a security person, helping CISOs and being a CISO, looking at things like very fast-moving ransomware worms and very fast-moving lateral movement, I want to understand what is the realm of the possible in IT and ad technology and marketing. They had already mastered all this stuff. That's where all these things came from. These big databases and these big streaming analytics came from the world of fraud detection and advertising technology. They have unbelievable sorcery and wizardry available to them. And in many cases, the security community does not until they start realizing what's available and adopting it as their own, which is what I did with my big project. So this came from Netflix, and this is called the Keystone Pipeline Architecture. And they started doing this in 2015. It's publicly available on the internet. You just go to SlideShare or YouTube or Netflix Keystone Pipeline and Google, and they'll go to their tech blog. Really cool stuff. So this came from a company that was at the time collecting hundreds of terabytes a day, net new, and it is now collecting trillions of events of petabytes every day, net new. So we have this idea of the producers on the left, all of the applications that look like Netflix, externally and internally, on your iPads, your phones, your Rokus, your computers. And anytime you log on and you watch stuff or even search for stuff, they know about it immediately. And let's say they are doing things like putting a new application together, and you're on your phone, you want to watch something, and they change a little piece of the UI, UX to improve it, but they notice that you're doing this on your phone. And that's called a frustration signal. It's a rage click. So the ad people and the IT CTO people understand this almost immediately. They see that, hey, we made a change, but on iPhone or version XYZ.123, we're seeing a lot of rage clicks. We need to kind of unwind that and make it better. So why can't we do that for security? But the answer is actually we can, and we can generalize this to anything in IT. So they came up with this idea, and these are all open source tools where you have this self-service UI internally for Netflix to understand what consumers or what producers are connecting to the Kafka, and then Flink is for stream processing, and that then goes to kind of a raw layer for a data lake for S3, which then gets operated on a batch environment, Elastic for some dashboarding and alerting, and then even another fronting consumer Kafka with more Flink for stream processing and other stream processors that other stream consumers that consume that stuff in near real time. This is just an example of what has been going on for many years, the kind of Silicon Valley web scale technology. And one of the things that I did was actually take this and adapt it to a very large traditional enterprise in the Global 100 that needed this kind of results, but didn't have the same exact technical skills, didn't have the exact same technical needs, but needed to get the impact of mean time to detect and a lot of different producers and consumers in different places, and get away from that kind of like lock-in of one big SIEM to rule them all. So how do we wrangle all these logs? One of the things we need to look at is this concept of data engineering. So data engineering is something we look at as a independent skill set outside, but related to as an enabler for data analytics. Data analytics is I have data, I need to make sense of it and give people recommendations so they can scale the business and be more efficient and make more money and catch bad guys, whatever it is that they do. The big thing about data engineering enabling analytics is you have more agility because you can add more and more data sources from different places and different levels in the stack and adopt new POCs very quickly. And so you have a business term called time to value. So if, again, in that earlier environment where you have a few sources that someone needs to analyze and it takes you weeks of manual data and it's not a repeatable, scalable pattern that is near automated, you're going to have a very long time to value. And by the time you get there, if you get there, you're not exhausted by doing the same thing manually over and over again. You're just going to spending a lot of money and time and missing out on competition. So the idea is connect the data sources to their consumers, whether consumer could be Splunk, could be Azure Sentinel, archiving in Glacier, whatever it is you need to do for analytics, storage, or a little both. You want to be able to mesh together on-prem things into the various clouds and also between the clouds, inter and intra clouds. And then there's the proliferation of SaaS apps are unbelievable. I'm doing some work with a cloud native startup, kind of started post-COVID, and they have less than 50 people and more than 50 applications via SaaS. It is unbelievably like mushrooms after a rainstorm. So you have to get a handle on what is producing logs and how do I get those logs stitched together into the pipeline where I can understand what's going on. And the reality is, if you're in data science, you're probably doing a lot of data engineering yourself, and you need the help from the data engineers whose job it is to get you the data into the tools you need to use in the right format. It's clean, it's presentable, and it's timely. I mean, it doesn't take too long to get there. If by the time it gets to your tool, it's already expired or not fresh enough to use, and what's the point? So data engineering and data analytics are really kind of cart and horse, and you need to be able to put them in the right order. I've seen many data analytics projects fail for lack of data engineering skills and tool sets. So this also applies to things like mergers and acquisitions, POCs for new vendors. And if you're a service provider, whether internally kind of an MSP or MSSP, or you're selling these types of services to others, every SIEM and storage fabric that you're using to deliver those services can be optimized in terms of reducing licensing costs, reducing storage costs, bandwidth, etc. All right, here's some logging principles. So number one, my org owns my logs, regardless of where they come from. Not the vendor, not Salesforce that is generating them in SaaS, not Windows Server on-prem. They belong to the Windows Server team. They belong to the company and whoever needs to analyze those logs, right? So my org, my logs, regardless of where they came from, SaaS, IaaS, on-prem, doesn't matter. Not the vendors. The SIEM vendors specifically, meaning the analytical vendors, should not own your pipeline. And they should definitely not be the sole storage location. Because the reality is, in 2021, and for many years now, no one single tool, even the biggest data warehouse or the biggest SIEM with all the money you spend on it, can meet all of your needs at the same time in the same place. So if you look at the iron triangle of its location, 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 in project management, it's cost, time, and quality, pick two. And in data engineering, it's scale, cost, and latency. So you can throw a lot of money at something, but if you want very high speed or low latency and very high scale, you're probably going to max out your budget and not be able to do anything with it. And so reality, there is no such thing as one tool that can do all these things and optimize all those three in the iron triangle. So the goal is to be able to enable logging, put it somewhere that you can store and analyze, and then create detections, whether again for IT troubleshooting or application troubleshooting or user rage click detections, or the Russians are in my network. You want to reduce the mean time to detect and gain that visibility. And it's iteratively. The more visibility you have, in some cases, the easier it is for you to get atomic indicators as well as more complex event correlation to be able to see, aha, this alone isn't bad, but this plus this in a particular timeline and sequence is obviously not something I ever want to see. We need to investigate and drop a net on it. With a very long time horizon, you have months or years even of data, and you want to be able to do things like threat hunting or just optimizing the way you deliver your products and services. But you need those logs somewhere outside of the SIEM, because the SIEM is not a place where you store petabytes net new a day for years. That just doesn't scale. So again, detection is great, but we want to eventually be able to prevent things and prevent something, not every particular incident or every particular exploit, but we want to be able to protect the company by saying, hey, I saw very quickly something that looks like an incident, investigated and intercepted it and mitigated the consequences by not enabling it to become a full-scale breach. And that's the idea in security. You can't protect and prevent every single thing, but once something catches fire, or even if you smell a little smoke, you go there and you fix it immediately. Aggregation beats conversation. Get the logs off the boxes and explore them. That's called exploratory data analysis. I hear a lot of people say, I don't know exactly what I'm going to do with this log source, so I'm just not going to bother touching these logs. I think that's not a good way to do things, because in today's environment, you can get logs, put them somewhere in a cheap storage bucket, and start looking at what they say, how they're structured, how many of them there are every second and every day, the data is, and all those things together will be able to tell you more about what's going on. So really explore the data around the data lake, or explore the space around the studio, as our friends from SNL did. And I'm not a data scientist, but I have actually used the sort by descending technique, including sort by ascending technique, which is very not fancy, to catch bad guys and red teams in near real time. And we'll talk about exactly how I did that. But that's an example of a thing where you can do exploratory data analysis, grab a bunch of data, let's say one day or a half a day if it's a busy source, or even 1 hour, it's a very busy source like DNS, and just start understanding what's going on here. Who are my top talkers, for example? So more logging principles. You want to be able to use the real-time versus batch. You likely need both, but real-time kind of in the data engineering world is just a form of batch that is very micro batch essentially, or the other way around, more correctly, real time is unbounded and batch is just a set of the unbounded stream. And so you can use various types of things like Spark and Kafka to do the analytics, but understand that real time is available. And if you're doing real time, you can also do batch. So open source, I prefer open source over closed, ideally with support. Obviously, Cloudera makes a living by supporting the very large scale open source projects, and that's where their expertise is. So scalability, you absolutely need to be able to architect your approach to have more log sources come up, including log sources that peak during a particular busy day. Let's say Wednesday morning at 11 a.m. is much busier than Sunday morning at 4 a.m. So you need to understand what your diurnal and kind of weekly, monthly, quarterly, or even yearly patterns look like, and there's ways to do that. And you want to be able to scale up to handle the load and be able to scale back down to reduce your costs, because obviously everything where you're doing computation or even just aggregation and forwarding, that takes some computing power. So now we're introducing the concept of forward compatibility. And this is really where the magic starts, and I get really excited about this. So in my big project where I implemented this at mega global scale, after a few times in smaller environments, I went to the DNS source owner, which was our kind of big takedown of a politically sensitive, very critical source. We didn't want to drop DNS. That's not something you want to do. And we want also to get their blessing and to have them be an advocate for our pipeline team by saying, hey, we gave them our stuff and it didn't break anything. In fact, we got some good insights on it. So the way I convinced the DNS team to do this was I told them, hey, what if I gave you an opportunity to give me, the pipeline guy, your logs one time, connect to my pipeline, and nobody will ever bother you again. I won't bother you again. And actually, anytime someone bothers you directly, send them to the data team, and they will, and the data team, meaning us, will give those requesters the data, and they won't be able to bother you anymore. Because the data is not yours. You just gave it to the data team, connected it to the big fire hose, and they took it from there. So that way you can say, we bother the log sources one time, whether in IT or InfoSec, we distribute and process many times downstream, and we have a pluggable input of a producer and a consumer. So the producer creates, the pipeline connects to it, aggregates it downstream to the proper consumers, get the logs that they need and not the logs that they don't need. And one example of creating forward compatibility also is to put a load balancer between the initial source and the initial aggregation. So let's say DNS, F5, and NiFi. And that way, the DNS people say, hey, we're just going to point our stuff at the F5, and the F5 will translate that into wherever the NiFi servers are, because one falls over, or one of them is underperforming, or there's maintenance, or we're just changing things in the stack. Again, we don't need to bother them. So forward compatibility is a huge thing where you're able to bother the source owners with very little. Another thing that is logging principles, you want to be able to set some metrics and some goals for yourself where you have the ability to monitor how fast is the data available to consumers once it hits the pipeline, actually once it's generated from the producer. So overall business goals, we're trying to reduce complexity of all that spaghetti ball of pain of the undocumented, unmanageable scripts that are owned by multiple people. There's no change control, there's no provenance, there's no real security there because someone could just take a script and modify it. We saw that with CodeCo, for example. I might want to look into that. And we want to create repeatable, scalable patterns that enable the following: rapid ingestion of new and, of course, existing sources, moving that data into existing and new consumers, like your existing SIEM, but also, say, a new data lake where you're doing all the POCs on the new analytical tools, and all your other analytical tools are going to be drawing from that. Things like digital transformation, cloud migration, zero trust, You're going to be able to enable some vendor leverage. Vendors that are storage and analytical vendors, once they see you going down this path, you will be having an entirely different conversation with them because they understand the power of data engineering, which is why they locked you into their proprietary agents, proprietary protocols. And so now that they know you are unshackling yourself and de-enmeshing yourself from their web, you are actually going to be free to just program that pipeline to send your logs to wherever you feel like it, whether to the SIEM and or not the SIEM or not the SIEM at all in some cases. And that results in some cost reduction and dramatic latency reduction in some cases, because again, cost, latency, and scale, the iron triangle of data engineering and analytics, no one tool can do everything really fast at scale without blowing your budget. So the goal, again, is dramatically lower mean time to detect and mean time to repair. You enable multiple analytical tools to do multiple atomic simple event processing and correlate on the back end for complex event processing. So you'll be able to see interesting things happening that are not obvious faster. So let's talk about a little about sizing. So what does sizing mean? Again, we're talking about first and last mile here, the goal of which is to enable analytics. The first mile, again, is to ingest, and the last mile is to redistribute. But in between first mile and last mile, you also need to understand, well, what kind of analytics are you going to be doing in the pipe itself? Because the pipe itself, including that first mile, whether it's an IoT in the middle of the ocean on an oil rig or in a van that's delivering things for a delivery company, all those things are edge cases, and that's that first mile. You need to understand what is it that I'm aggregating and where am I sending it to? And the pipeline is its own consumer. So you really need to kind of get in the headspace where the pipeline itself is an intelligent pipeline. It has the ability to detect and operate on things before it gets to that kind of big database or storage layer that is the data warehouse kind of traditional thinking. So Minify agents, as an example, you want to understand how many endpoints, servers and desktops, and what kind of processors are we going to use in Minify. And things like IoT or laptops on the internet with zero trust, you don't have them necessarily all on VPN 100% of the time. So you need to be able to get telemetry from them directly over the internet to your processing pipeline and eventually consumers. NiFi itself, you want to understand what are the total events per second, average and peak, and gigs per day or gigs per second, average and peak, once they get into NiFi from the initial sending units like Minify, and what kind of processors are going to be implemented in NiFi and Minify in order to understand the computational intensity. Kafka itself, which sources are going directly into Kafka, or which sources come into NiFi first and then into Kafka. Sometimes it's relevant to go to Kafka directly. Many times NiFi is better. And then the ETL, or extract transform load, which is the kind of schema on write, old school SQL data warehouse type of thing. But in many cases today, it's ELT, or extract load transform, because we're not actually doing schema on write, we're doing schema on read, which is more flexible, raw data layer, or what most people call data lake. I call it S3. So in the pipeline, again, you can do ETL or ELT and analytics in Minify, NiFi processors, and in Kafka and Spark Streaming or GFS and Flink. You look at these things as intelligent processors before the data even gets to the data warehouse or the SIEM. And these are just some examples. Out along the edge is always where I burn to be. And here's an example of dropping data that you don't need. And you can generalize this to really anything. But this is just a universal example, I thought, in that first mile and analytics tools where people need to understand, okay, what is it that I don't really need to send downstream? Because it's costing me three ways. It's costing me bandwidth, costing me CPU, it's costing me RAM, and it's costing me licensing and storage costs, right? So every time someone opens a Google Chrome browser on an endpoint and they're being monitored by a DNS log or a proxy, for example, this is something that gets generated. So this is a sample Infoblox DNS query log. There's also the response, which you didn't put here. It's actually two of these and longer. But this is an example of a thing that you would find, excuse me, in a DNS log coming from Infoblox. So this is something that's entirely useless. Nobody cares about this, even the paranoid security folks like myself. You would care about the secondary, or once they go to google.com, they type in things like Adobe Reader update, and that's a bad sign, right? But you would see that in the referral header for the next one. So that's actually an example of something you don't need. So you'll be able to drop that entirely. In some cases, you don't drop the entire log. You just filter inside of a field in a log. So for example, some data sources have very privacy invasive things like GPS coordinates, unbelievable, very privacy invasive. And you maybe not necessarily want to collect that. Or in some cases, you want to anonymize that or make that less granular or make it go away for kind of essentially declassifying data so that it has less privacy issues and the devs can work on it in a slightly less restrictive way. Other things like noisy CRUD, vendor version number, I've seen like 50 characters every log. It's, proxy vendor X and it's version 123, and it's literally 50 characters out of a 800 character thing. So now you're starting to save 3%, 5% just by removing that, right? And writing a 1 in there. So you're adding percentages over percentages over percentages over time, and you kind of start aggregating this kind of data cockpit of savings knobs and switches. We're able to add a bunch of little savings that add up to quite a bit. Another thing you can do is deduplicate. So various homepages of approved websites that are not of concern. We talked about Google, but also let's say you're going to finance.yahoo.com and someone has something that's going there. I've seen it going there sometimes hundreds of times a minute. And you can say, open up a window, close a window after say 2 minutes or 1 minute or 5 seconds, whatever window you want of time. And you count the number of exact same logs with obviously different timestamps. And then you deduplicate that by only sending one log that says n equals 19, for example, in this 2 minute window, instead of actually writing 1, 2, 3, 4, 5, all the way up to 19 separate logs for the same thing. The cool thing about that is you can actually do things not just in proxies, for example, but also, for example, if you have IoT sensors and the manufacturer insists that they can't change this, they log every 1 second or even every 1/2 a second. And you only need the granularity of, say, every 5 seconds or every 10 seconds. So just by changing that, by ingesting it into Minify or NiFi, opening up a small window every few seconds, adding them together, and then sampling an average, which is something you can do in NiFi, and you send that downstream. So now you're not sending 10x the logs that you need, you're only sending the logs that you actually care about, which is, did something get over a temperature threshold? Did something get over a pressure threshold? If not, then just send one average sample. So you're already sending 80%, 90%, maybe more. You can also do things like shrink. Obviously, we didn't invent compression, but there are ways to literally just compress things into a zip file or a GZ file, but also convert formats. And Laura talked earlier about converting from XML to JSON for fast searches, or converting from JSON to CSV, which we'll talk about in a second, for bandwidth optimization for storage and analytics. So hacking the water meter, one of my favorite things. The pricing model of analytical tools and obviously storage tools is how many gigs a day are you ingesting and how long are you ingesting them for? How are you keeping them? This sadly creates an environment where you have winners and losers for your various sources. And one example is a key value format, and the other is a CSV, or what we are very familiar with, concept-rated values, also otherwise known in Excel. So in the first column, in the first row here, where it has time equals XYZ, and then time equals XYZ plus a millisecond, and then the next log and the next log after that, you're seeing it's the same log, but in the log, we're explicitly writing the key value, the key of time with the value of XYZ, and the next log is log number 2, with the next millisecond over. So the key of time is actually written explicitly in each log. But what we can do by changing it to CSV is to reduce it from 5% even up to 65% or more, just by converting it to CSV, depending on the key value ratio in the particular log source that you're using. What that allows you to do is either pay less or just ingest more. So similar to kind of a fantasy land where you're adding this magic fuel additive to your car and it doubles your mileage. And here's a silly example. So the keys for the key value pair on the left here is employee details, such as yellow employee name, green email, and purple job profile. So we have a person with employee name James, email James at Gmail, and job profile of senior developer. And the second log is employee name Smith, email Smith at Gmail, and job profile project lead. Now this is a particular key value format, and by converting it to CSV, where the key is still the same, employee name, email, and job profile, it's written explicitly on line 1, but all the lines thereafter, and imagine there's 1,000 of these, you have the actual values that are implicit to the keys based on their position in the columns in the CSV, right? So employee name is James or Smith, email is James or Smith, job profile is senior developer or project lead. And so here you have an example with just 2 logs, 2 entries, that you have a situation where you have about 200 characters on the left and 91 characters on the right. And that's just, again, for 2 entries. Obviously, the longer the CSV is, the more savings you're capable of doing. And again, every source is a little bit different. Some sources is not very helpful in terms of ROI. Some sources is very helpful and worth the computational work. So let's talk about speed. So we want to get the logs off the sources as soon as possible and not do this in like 5-minute batch jobs with scripts. We want to be able to say, grab an API or grab a folder and tail those logs and move them as soon as they're created on the box. We want to be able to tag them, enrich them, convert them, redact them, etc. On the box itself or at the very next hop, and then do more work in the pipeline. And that's that first mile magic, because you're really moving a lot of the analytical intensity upstream of the main SIEM or the main analytical tool that you are now starting to free yourself from. And you're able to start doing things like attacking the gated queries, which are these kind of big bottleneck, very long query time. In some cases, they even time out because the analytical tool is not optimized and you're just giving it a bunch of crap to operate on in the wrong format or in the wrong way. So find the queries that take the longest and attack them first. And in some cases, take those queries and disassemble them into things that you can move upstream and actually get the answers for in the pipeline. And that way you're iteratively shrinking the query times, and over time, you're able to see a massive additive value of reducing time to detect. So what does it mean to organize your sources? It means taking a look at your existing prod sources and then some of the new greenfield or dev sources, make a list of each, and start playing with the new sources first. Now, why would I say new sources first? Take the lowest volume new source first. What that'll give you is net new visibility. So a CIO or CTO or CISO says, hey, I don't know what's going on in those applications, what's happening in your containers, the new network that we just acquired with the new company, I don't know what's going on there. So take a look at some low volume new sources that are not fully productized yet and they don't have a kind of internal hard SLA, and understand what that looks like. In Parallels, we're existing things like, do I use agent or agentless? And where else do these logs need to go in addition to where they're going today? Though that's for prod. With new, you obviously have a greenfield by definition because they aren't going anywhere. You're not even collecting them yet. So here are some of the things you need to look at. How many events per second are there, peak and average? How many gigs a day, peak and average? And again, where are they coming from and where are they going? So create your own spaghetti ball of pain for each of the log sources, from producers to consumers. So existing sources are a source of danger, and you definitely don't want to be flying rubber dog doo-doo out of Hong Kong. So these are prod sources. You got to be very careful of them. If you need to use the prod sources, you can get them in an offline format from the source owner and work the use cases for ETL or ELT, code the pipeline to do the analytics upstream of the SIEM, and run those logs through them over and over by tweaking the analytics, and you'll be able to show results in terms of privacy enhancing, moving GPS stuff out, or declassifying them, or moving them into encrypted format, or changing it from XML to JSON, or JSON to CSV, or whatever it is you're trying to do. And then you say, hey, I have done the work in a non-intrusive way, and I have the political capital now to say, here's the ROI and analytical benefit for this, and here's what we're going to do in terms of planning for onboarding and cutover. You're in a much better position politically to ask for the logs from production after you've done this offline piece. So why do we have the pipeline? We want to actually do things with the data. And the cool thing about things like Kafka, Spark, Flink is you're able to take stuff from the first mile and redistribute it to the last mile. Kafka has something called publishing and subscribing, or PubSub. You're able to have people subscribe to the data that they need and not the data they don't need. So in security, we have a very busy source called EDR, things like Carblack, CrowdStrike, or SentinelOne. They record almost everything that happens on the machine, and they're very noisy. Many terabytes a day on a busy network. And so few people actually need the raw EDR channel. Many people in security need to see the EDR alerts and move them into very specialized tools and understand what they mean. Things like proxy logs that are already deduplicated versus the raw, things like how fast is something happening on DNS, which will look at things like lateral movement or just IT troubleshooting. Those are things that are actually very helpful in terms of this concept of publication and subscription. So you're able to customize the kind of data you need from the places you need it and to the places you need it. So Jew Russians buzz your tower on the regular, and here's an example of what you can do with that kind of stuff. So count all the things again in a time window, say 60 seconds, open the window, close the window, and count the DNS queries from an individual desktops, and sort by descending, my favorite technique. The number of repeat events per that time window is, by definition, the rate. So you have, on average, let's say 200 DNS queries from a given box, and then it goes up to 15,000. And this is an example I've seen. You now have a threshold or a inflection point, kind of where it goes hockey stick, where you have the ability to say, I don't like what's happening on that desktop or that server. This is anomalous. And you send something to IT for troubleshooting. You have something to security for, is this malice? Do we need to isolate this desktop or do forensics on this? Where is this desktop talked? What has it done? What kind of identities and binaries landed on, et cetera? So this is actually a corollary benefit of doing the deduplication of the stream logs, because you're already doing that on a routine basis, and you're able to get that meta signal of a rate by deduplicating it. And that's actually sent downstream using the deduplication we talked about earlier. So counting is done on a routine basis, and you sort events things like likeness or deduplication, and you keep that count as a signal, because that is a meta rate that is actually its own interesting signal you can use for troubleshooting and malice detection, things like lateral movement, too many logins, brute force stuff on identities, or certain types of file deletions or modifications implying something is executing malware on a server, like ransomware, all kinds of endless use cases. But this idea of moving this type of analytics upstream and doing it in near real time before it even catches the database or the index of the SIEM, incredibly powerful to reduce mean time to detect and make the SIEM focus on things that it's really good at. More real-time streaming analytics, a little bit of prep. So you want to be able to look at things relating to the changing of the logs, and there's things that you can change inside the logs. You can change the format or schema of the logs. So inside the logs, we talked about redaction, and format change, we talked about key value to CSV or CSV to JSON, because some tools like Elasticsearch need the specific format and not the way it came off of the box. So it comes off the box in CSV, Minify, NiFi grab it, send it to Kafka, Kafka sends to NiFi, and then boom, you send it to Elasticsearch. Or you just get a subscriber off of Kafka if you need to. But either way, that first mile is critical, because you're doing that CSV to JSON conversion in real time, and then it's done for you. So the format change from JSON, for example, to Parquet or ORC or other things that are columnar format, massive storage savings well into the double digits, sometimes 80, 90%, again, depending on the particular source in terms of key value pair ratios. But if you're spending a lot of money, hundreds of thousands of millions of dollars on long-term storage for something, and it's in something like a JSON, and you're not looking at columnar formats, you should be, because those are things that can save you a ton of money, even on cheap cloud storage. Order of operations, identify the source and what layer they're in. So we have a virtualization layer, we have the server itself, the database, and application. So let's say, example, we have Windows 12 on VMware, and then there's a SQL Server and an application on top of that, or in relation to that, and you want to move all those layers of log sources into the LAN aggregation. So you can have Minify or other things like that, collect the logs and send them to the aggregator, like a NiFi. It gets ingested, so now it's in the pipeline. You got that first mile win, which is huge, because now you own these logs. You can do with them whatever you want in the pipeline. Analytics, distribution, all that kind of stuff. And so you're using these various things to ingest, whether it's NiFi or Kafka. You could use Amazon Kinesis, Event Hubs in Azure, Stackdriver from Google. Don't care. It's all the same to me. But you are able to send that downstream to wherever it is in the cloud that you're using. You can do the transformation we talked about for processing, and then some of the analytics in pipe, even after it came out of the SIEM, because there are then going to be alerts sent out of the SIEM, and then you can resubscribe through Kafka to say, hey, who wants these alerts wherever they are. Multiple places you can send storage on off-prem, and then again, there's realistically a lot of small iterative loops where you don't have just kind of this one hard left to right, but there's a lot of little loops in place if you're doing this correctly. So at the end, things you should do now, organize your data flows with just data flow diagrams, whether it's a whiteboard with a picture or some sort of charting mechanism. Understand your spaghetti ball of paint as it exists today, because it probably does. Understand your producers and consumers today and tomorrow, your current analytical use cases in terms of latency and cost and scale, and identify net new use cases, because again, exploring the space around the studio, what would I be able to do if I could find things very quickly upstream of the main SIEM and use really cheap storage and, let's say, operate on, cloud native serverless, right? So those are options that are now unlocked because you're able to recapture ownership of your pipeline through that first mile ingest and redistribute it to the last mile to anywhere you want, in any way you want it. You probably want to reach out to your privacy officers, especially if you're handling California or European Union type of information, because they'll want to know what it is that you're doing with these data. And cybersecurity is typically a good exception. You want to tell them that you're doing risk scoring of transactions or accounts of machines, and not risk scoring people. Those are two very different things. When you're risk scoring people, actually, like insider threat models, which is something that these techniques can help with, you usually have a higher level of scrutiny with privacy, and that's fine because, again, Cloudera has dealt with a lot of that at the very large enterprise level in terms of where does this data come from, who accessed it, do with it, and that's all logged and really provisioned in terms of access control and all the good data governance mechanisms. So realistically, most big enterprises are dealing with on-prem and cloud multi-year transition, digital transformation, et cetera, and understand how your data controls work wherever the data goes. And this is also something that Cloudera is doing, where you're dealing with multiple clouds, including on-prem, from kind of one command center. And that's it for me.
Well, thank you so much, Gal. That was a wealth of information, lots of wonderful insight, especially around, targeting your largest query to figure out where you want to go with your data pipeline, and talking about how these transformation from XML to JSON or JSON to CSV, that changes the volume of data or the size of the data that you need to do for analytics, and that's going to change the game as well. So I really love the overview and the deep dive. I almost say you need to write a book about this, but that will be another job for you for one day. Let's go straight to the Q&A. I've got a list of questions. I'm going to start the first one from Bill B on YouTube. In what cases would you recommend having IoT devices directly transmit data to Kafka instead of going through NiFi?
Well, we talked about in one of the first slides about concurrency. And so you need to understand how many of these things are going to be talking to Kafka directly, and also over what type of network. So there's some security issues and some performance concurrency issues, because my understanding, and I'm not a global Kafka expert by any means, but my understanding from people who are, is it's really not designed to handle 6 figures of direct connections from random devices kind of popping up and down on the network, which is what in many cases IoTs and laptops and mobile phones are. So you have to look at the concurrency of it. What is the scale of this thing? Is Kafka really the direct use case possible? And then you have to look at what is it that is on those IoT devices that can even talk to Kafka in terms of the right protocol. Can it authenticate to Kafka? Can it encrypt the transmission? Can it authenticate securely? And then actually do the various processing things from IoT before it even gets to Kafka? Because we talked about, for example, sensors, temperature or pressure. In many cases, you don't have the ability to fully configure the type or frequency of logs. And so you'll want to have something like a Minify or NiFi intercepting that and doing that processing before it gets to Kafka. And that's just one way to do it. And you're then decoupling the concurrency problem from Kafka, and you're moving it upstream to a Minify and NiFi, which I've seen handle quite a bit of that as this kind of interim initial aggregation tier. I hope that's helpful.
Okay, I think so. We have another question from Sam, LinkedIn. What makes NiFi different from traditional ETL tools?
So NiFi can do a lot of things. And if you go look at the NiFi processor list, again, there's this concept of ingress, and then egress, and then route on attribute that we talked about earlier. So it can do a lot of things to grab the data. It can do a lot of things to route the data, and it can do a lot of things to put the data where it needs to go. So it is, in my mind, one of the best tools I've seen to take all kinds of old school protocols like syslog and FTP and SFTP, all the way up to webhooks and HTTP and Kinesis and all kinds of very modern kind of cloud native protocols or tools and services. And it allows you to very flexibly connect them in an almost a universal adapter type of fashion. So if you think about a bunch of hoses with a lot of different types of threads and different ratios, you can take NiFi as a kind of universal adapter and say, here's a source, here's a consumer, and I'm just going to put NiFi in the middle as a first and last mile. And that's different than ETL because you have the ability to do this in near real time, and you don't have to do it with a hard schema on write like you're doing for kind of data prep for a SQL data warehouse. This is really designed, and you can certainly do that in NiFi, and you can put stuff in SQL, obviously, it's one of the processors. But you can also, in addition to that, do the more ELT as opposed to ETL, where you're able to write to a raw layer, and the data lake will then come back to the Kafkas and the Flinks and the Sparks that do the very heavy processing for up to and including the data warehouses. It's a little bit of a munched answer, but I hope that was helpful.
That was very good. Thank you so much. Very clear. A question from YouTube. Can NiFi use other agents to collect data from the edge? Yeah.
Other agents.
So other than Minify, right?
I have seen this in experimental environments, including the universal forwarders. Where I've seen them, it's always been a bit of a hack. And it's something that I would suggest you need to look into it specifically in terms of this particular agent. What is it sending, and how is it kind of cooking or munging the data before it gets into the transmission mode? Because you'll then have to do a little bit of additional data engineering because you're using a more proprietary agent in some cases to essentially uncook the data, if you will, so that it's less of a proprietary format. And in some cases, what you'd have to do is send it downstream to an analytical tool that does some operations on it to maybe do some line breaks or other things like that. And it really depends on which agent and which NiFi processor is built in. If you have a particular use case you're worried about, I'd get with the NiFi project and or Cloudera people and say, here's something I need to do at scale, and it's something that I don't think is supported. And I've seen them actually be pretty responsive to that. So I'm mostly familiar with the Minify to NiFi agent piece. Where I've seen other stuff is we do tool hops. So we have an agent going to a particular aggregator that is proprietary to that agent, and then we send from that agent the raw layer into NiFi and then do the operations that are necessary. So I don't obviously have visibility into every project that Cloudera has, but that's what I've seen.
Okay, great. And the last question, I think, there's another one. All right, let me start with this one. As an investor and developer, I hope your company continues to grow. Thank you. I hope so too. Please keep up the great work. Okay, so that's from Young Grizzly. All right, so that's a great question. The last one, I think you've already answered it, but I kind of want to just bring it back to you is, why not use Kafka for all data pipelines, right? They seem to be in the middle of everywhere, but why not for all data pipelines?
Yeah, and Kafka is a great tool, and I like Kafka, and Cloudera obviously supports Kafka as part of CDF and CDP, so we're not bagging on Kafka in any way. I've just noticed that the reality is that the limitations of Kafka as a message bus and an analytical tool, in some cases both, don't allow it to do as many things at the edge on the first mile and last mile as NiFi. And that's just been my experience, even in surprisingly places like EFK stack, that is the kind of built-in logging stack that comes with, for example, OpenShift container platform. We thought Fluentd would directly write to Kafka. It just didn't work in our POCs, and we tried it with NiFi and it worked great. So everything is different. And then there's, in addition to that idea of being the kind of universal connector for the first mile and last mile, which I have had great experience with, there is the issue of concurrency. It's just not necessarily designed for massive amounts of distinct sources popping up and down in the six-figure scale. So if you have a massive enterprise or a massive amount of IoT devices, I don't think you're going to have a good time just dropping all of those individually connected into Kafka directly. And that's a concurrency issue more than a security or anything like that.
Okay. Well, I think that's all the questions we have. Thank you for being such a great sport, Gal, for just answering a lot of these questions. Also telling us the story of why the first mile of the data pipeline is so important. I know we have the title calling the first mile, but I think the last mile is just as important as well. So that's all the question we have. And now we're heading to more information. So for the audience, if you want to learn more about Cloudera and our products, go to our a user page, a cloudera.com users page. We have videos, tutorials, and events that you can follow up with. If you want to learn more about our Cloudera data platform, we do have video tours that you can sign up. Here's the link that you can click on or write it down. We can send that to you. And if you're really enjoying our meetups, I'm really happy you are, because we got a lot of incredible speakers and insight information that you can leverage. So click on that link. We have a list of meetups to come. And if you want to know when is our next meetup, yes, thank you, is Get Your Analytics on Time. It is next week on Tuesday, May 18th, and it's from 5 p.m. to 6 p.m. Central Time. So now it is raffle time. So I hope a lot of you stay and stuck around for that. I have refreshed it, so somebody will click and choose a winner.
Refresh.
I just hit refresh. There it is. It's Young Grizzly. Please stick there because you got prize number 1. And then for the second winner, all right, I'm going to hit refresh. It's Cosmo Kramer. I'm beginning to really like these names here. You have won the second prize. Congratulations. What I recommend for the winners is please send your contact information, your mailing address, your name, and send it to socialmedia@cloudera.com, and we will send you the prizes, okay? So this concludes our meetup, and I want to thank Gal for being a rock star and explaining how the data pipeline works and what are some of the principles that we all need to follow to learn to make the pipeline more successful for your analytics. And on behalf of the team, I'd like to thank everyone for coming out and helping and having such a great time with this event and asking some really, really good questions. We look forward to seeing you again and for the next future data meetup. Thanks again for joining us and have a good evening.